Hey there. In this video, I'm going to compare two modeling softwares, Plasticity and FreeCAD. I decided to open with a shot of these two cars side by side because I think they perfectly represent the philosophy behind each program. Plasticity is presented as a CAD tool for artists, while FreeCAD positions itself as a full CAD suite for engineers. At first glance, both softwares seem to target very different modeling needs, but the line between them isn't always so clear. In this video, we'll explore where these two programs overlap, and more importantly, which one is the right fit for you and your projects. The video is divided into chapters to help you easily find the sections that interest you most. Just a quick disclosure, I'll be sharing my perspective as an industrial engineer based on the needs I have when modeling in 3D. These may be quite different from those of a 3D artist. Let's get started with the comparison. Plasticity is on the left side of the screen and FreeCAD is on the right. Alright, the first thing we're going to compare is the UI, and we'll take a quick tour of both programs. Plasticity's interface is clean and modern. You can easily hide or show the outliner, and the different elements are neatly organized into solids, sheets, and curves. There's no feature history since Plasticity is a semi-parametric modeling software. On the right side, you have a panel that can be hidden as well, giving you access to visual settings like shaders, which help you inspect the surface quality of your 3D model, as well as other options like snapping or custom plane creation. You can easily hide both side panels, either by clicking the dedicated buttons or by using keyboard shortcuts. On the left, you have access to all the 2D creation tools like lines, curves, and circles, but also solid creation tools and a very handy measurement tool. Operations like extrude, loft, or sweep are hidden by default. You need to click the magnifying glass at the bottom to bring up a search bar. Plasticity's interface is designed to be fast and minimal. It pushes you to use shortcuts, which is actually a great way to boost your modeling speed. In FreeCAD, the interface is a bit more cluttered and can feel less intuitive at first. On the left panel, you have the full history of your model, with direct access to every feature in Sketch, making it easy to go back and make changes. Modeling operations are laid out in the top toolbar for quick access. For someone just starting out, this interface might feel overwhelming, but all the tools are there to let you model and fine-tune every single parameter. Because of FreeCAD's nature, you have many options to customize the UI, moving panels around, applying themes, hiding certain toolbars, even creating radial menus. The interface is very complete, maybe even a bit too much. The second point I want to talk about is the comparison of 2D sketch creation. We'll recreate this sketch in both software programs. It's a moderately complex sketch with several constraints that can be a bit challenging to replicate. Let's start with FreeCAD. To start drawing, we first need to create a sketch and select a sketch plane. It's like choosing a flat sheet of paper where we want to draw. FreeCAD offers several tools to create shapes, along with different constraint tools to define relationships between them. In our case, we'll use the polyline tool to draw the outer contour of the shape. Then, using constraint tools like dimensions, parallel, and perpendicular constraints, we'll lock the shape in place. This is the typical workflow you'll find in most CAD software like Fusion or Onshape. It's a very convenient approach because it lets you place everything precisely and makes it easy to modify later. As you can see, there's nothing particularly difficult about creating and constraining this sketch in FreeCAD, and the result is perfect. Now let's see how to create this sketch in Plasticity. Unlike FreeCAD, drawing works differently in Plasticity. We draw directly in 3D. There are still drawing tools, but no constraint tools. Constraints are applied automatically as you draw. It's a sketching method that's quite similar to SketchUp. To make it easier to draw on a flat surface, I'll click on the top face of the navigation cube. This aligns the view perpendicular to that face, which makes sketching a lot easier. Using the line tool, we'll start by drawing the bottom line. To enter its length, you need to press Tab. That gives you access to the dimension field where you can type in 25. Note that you won't be able to edit the dimension afterward. We'll repeat the same process for the vertical line of 10 millimeters. Now things get a bit more tricky with the top line. When you press Tab, you can enter not just the length, but also the angle relative to the horizontal. In our drawing, the angle is 132 degrees from the vertical axis. To get the angle relative to the horizontal, we subtract 90 from 132, so we need to enter 42. Also note that I intentionally made the line longer than needed. We'll be able to trim it later. Using the Shift+D command, we're going to duplicate this line and move it to the bottom point, since both lines are parallel. To align the 2 points, we need to press G to activate the Move command, then F for the Freestyle option, which lets us choose the point we want to move from. After that, we can move the line to match the 2 points precisely. Through these 4 lines, I think you get a good sense of Plasticity's drawing philosophy. I'd say it's similar to SketchUp or AutoCAD in its approach. By holding Shift, you can access additional constraints, and the automatic snapping is also well designed. With a bit of geometry knowledge from school, you can pretty much create any shape you need. Alright, now let's take a look at how basic solid creation works. To create an extrusion in Plasticity, you just need to click on the contour, and a gizmo appears that lets you extrude it freely. You can also set an exact value using the menu in the bottom left. In that same menu, you'll find options to extrude at an angle or to extrude with a specific wall thickness, which can be super handy if you're creating things like walls or shells. To create an extrusion in FreeCAD, you first select the sketch and click on the pad icon. In the task menu, you can define the extrusion length and also set an angle if needed. However, there's no option to extrude with thickness. Overall, both tools work in a similar way in each software, but Plasticity allows for quicker and more intuitive extrusions. Now let's take a look at the revolve operation. In Plasticity, you first select the contour, then look for the revolve tool. You'll need to define an axis of revolution. In this case, we'll select the 2 points on the left side of the sketch, and the revolve is applied automatically. In FreeCAD, you first select the sketch you want to revolve, then click on the revolve tool. By default, FreeCAD performs the revolution around the Z-axis. But in our case, the sketch is off-axis, so we need to change the axis parameter to select reference and manually pick the edge of the sketch. The operation works similarly in both programs, and you can also set a custom revolution angle if you don't want a full 360 degrees. The loft operation works a bit differently. In Plasticity, you simply select the 2 profiles and then find the loft tool. The loft is created automatically. It also works if you have multiple sections. In FreeCAD, the process is quite similar. You select the section sketches and click on the loft tool. It also works with multiple sections. Just like in Plasticity, FreeCAD has no problem handling it. The main difference lies in the options available. In Plasticity, you can create a loft using guide curves, which can be really handy. This option isn't available in FreeCAD, so you'll have to find a workaround, which tends to be less intuitive. Now let's take a look at the sweep operation. In Plasticity, just search for the sweep tool, then select the profile first, and then the path. The sweep is applied automatically. You also have the option to adjust the scale at the end of the sweep if needed. There's also a twist option, but I'll talk about that a bit later. In FreeCAD, you can directly select the profile sketch and then the path, and click on the additive pipe icon. The operation is applied immediately. However, you don't have the scaling option, but there are other interesting options available, which I'll show you in the next example. Let's see if we can perform a sweep operation with multiple sections along a path. In Plasticity, when you select the 3 sections and then the path, the result doesn't come out as expected, so you'll need to find another method to achieve it. In FreeCAD, to perform this operation, you first select the base sketch and the path. Then, in the sweep options, look for section transformation and change the transform mode to multi-section. After that, you can select the different profiles, and the operation should work without any issues. Plasticity has a feature that isn't available in FreeCAD, the pipe tool, which lets you create a sweep of a circle along a path directly. without having to sketch the circle manually. It's not a game changer, but it does save a bit of time. One tool, however, that is a game changer compared to FreeCAD is the twist option in the sweep tool. It allows you to create twisted shapes by entering a multiple of 360 degrees. This makes it easy to model complex forms or spirals, which is especially useful if you want to design springs that aren't perfectly straight. Unfortunately, this option isn't available in FreeCAD's sweep tool, so you'll have to find another solution to get a similar result. So far, I've compared the two programs from a theoretical and basic point of view. Now, I'm going to model this part in both software. If you're a regular on my channel, you've probably seen it already. It's a bicycle stem. I think it's the perfect candidate to compare solid modeling in both programs. I'll speed up the footage, but if you're interested in a full tutorial on how to model it, you can check out the video linked in the top right corner. Like before, plasticity on the left, FreeCAD on the right. As you can see right from the start, modeling is much faster in plasticity, mainly thanks to the way constraints are handled directly while drawing. There's no need to go through separate constraint tools, which saves a lot of time, and that doesn't come at the cost of precision because both models will end up identical, but you'll see at the end what kind of trade-off that speed comes with. That speed also comes from the difference in responsiveness between the two. In FreeCAD, there's always a bit of waiting between steps, creating a sketch, closing the sketch, starting the operation, doing the extrusion, then closing that operation. It all takes time. Plasticity, on the other hand, feels much more responsive. When it comes to modeling the bolts and their holes, I have no choice but to go full caveman and model them manually. Plasticity doesn't have a hole creation tool or a fasteners library, which, in this specific case, is quite frustrating compared to FreeCAD. That said, it's worth noting that even when modeling the bolts manually, the overall modeling speed is still faster. Unlike FreeCAD, assembly is done directly using the Move tool. It's not that big of an issue in this case, since the snapping tools in plasticity are quite good. That said, it's still a different approach to 3D modeling, and that approach might not appeal to everyone. It really depends on your workflow and your personal preferences. After designing our part, it's important to check if we can export it for 3D printing and make sure the mesh quality is good. In FreeCAD, there's a dedicated workbench for converting solids into meshes, allowing you to control both resolution and structure. So on that side, no problem getting a clean mesh for export. In plasticity, when you choose an export format, you also get the option to set the mesh resolution. The options aren't as advanced as in FreeCAD, but they're simple and get the job done. When you import the files into a slicer, like Prusa Slicer for example, the parts have good resolution and slice perfectly. You can send them straight to your printer without any issues. Speaking of 3D printing, if you're looking for a reliable supplier for your prints, I can recommend PCBWay, who is sponsoring this video. They're a trusted name for both DIY and industrial projects. I had the chance to test their 3D printing and CNC services to create a bike chainring, and the quality was truly professional. You simply upload your 3D file, select your options, and you're set. Their standard 3D printing options are excellent. Plus, every new customer receives a $5 coupon for their first order. A big thank you to PCBWay for supporting this video. Often after 3D printing your part, you realize that some things aren't quite right and need to be adjusted. Let's take a closer look at that situation. Modeling in plasticity is semi-parametric, meaning you can adjust a few elements after modeling, but not everything. In contrast, FreeCAD is fully parametric, with the ability to use variables. For example, if I want to change the diameter of a hole, I simply edit the sketch. Or, I had created a variable to control the length of the stem. I can update it in just 2 clicks, as you can see. But in plasticity, that's a whole different story. Changing the diameter of a hole is fairly easy, but modifying the overall length of the stem, you almost have to start the modeling process from scratch. Some might say that the speed and comfort of direct modeling in plasticity make up for the lack of full parametric control. In the end, it all comes down to what suits your workflow best. But as you can see, even with the video sped up, it still takes quite a bit of time to adjust the stem length in plasticity, compared to just a single click in FreeCAD, especially since you also have to manually adjust the position of the bolts as they're not constrained to the surface of the stem. Now let's move on to an area where, in my opinion, plasticity really shines compared to FreeCAD, and that's surface modeling. On my channel, I often model bike parts, and when it comes to carbon fiber components, the shapes are much more organic. I've prepared 3 tubes that could represent the junction at the head tube area of a bike frame. I'll show you how we can merge them together to create a smooth transition. I modeled the 3 tubes in FreeCAD and then exported them to Plasticity to make sure I'm working from the same base geometry. Let's start by seeing how this surfacing operation works in FreeCAD. We need to start by creating connection edges between the surfaces. To do this, we use the Blend Curve tool. You select the 2 edges you want to connect, then click on the tool to generate the junction. This tool can be a bit finicky. It tries to connect the edges with tangency by default, but sometimes it's in the wrong direction or not positioned correctly. Fortunately, you can tweak these settings in the menu on the left, including the continuity level. In our case, we'll keep it at G1 continuity. I'll speed up the process because it's exactly the same as for the first curve, but as you'll see, this tool isn't very intuitive. You'll often have to rely on the settings in the left-hand menu to fine-tune the parameters and get a proper result. To create a smooth tangent surface in the middle of the tube, we first need to generate some surfaces. To do this, select the central blend curves, go to the part workbench, and perform a simple extrusion. The length doesn't really matter at this stage. Next, switch back to the surface workbench. Using the filling tool, select the contour edges. Don't forget to include the blend curve. To control the continuity with the adjacent surfaces, click on each edge and set the mode to face and the continuity to G1. It takes a bit of time to set up properly. Once it's done, you can see the result is quite satisfying and matches what we were aiming for. Now we need to repeat the same process for the upper part. I'll speed it up since it's exactly the same as the bottom section. As you can see, the surface dips slightly in the middle, which means we'd need to add an additional guide curve to improve the shape. I'll continue anyway and fill in the center surface using the same method. But as you can see, the result is far from what we'd expect. Even trying to create a large patch doesn't help. The result is pretty bad. The only way to try and fix this would be to keep adding constraint curves or to simplify the junction altogether. But I know I'm asking a lot from FreeCAD here. It's not really designed to shine when it comes to surface modeling. This case just seems a bit too complex for it. Now let's see how to do this in Plasticity. You'll notice it's much simpler and faster. To create a blend curve, just select the 2 edges and press Shift+B. This automatically creates a curve with G2 continuity, and by pressing Tab, you can switch to G1 if needed. You repeat the same process for the other 4 curves. As you can see, the time saved compared to FreeCAD is huge. Next, to get a nice continuity, we need to extrude the middle curves. To do that, just select them, press E, and extrude along the Y-axis. By pressing H, we'll hide the blend curves that are overlapping with the extruded surfaces, so we can be sure we're selecting the actual surface edges, not the curves. Then, while holding Shift, we'll select the bottom edges and press F to bring up the patch function, which will let us create a surface. You can press Tab to change the continuity to G1. We can now hide the blend curve and repeat the same operation for the top section. As you can see, unlike in FreeCAD, there's no dip in the top surface. Using the same technique, we can now check if the result is better for the central surface. And just look at that. The result is perfect. The surface is smooth and blends seamlessly with the tubes. The comparison with FreeCAD is a bit embarrassing. The last point I'd like to cover here is reverse engineering. With 3D scanning technology becoming more accessible and affordable, I think it's crucial to see which tool is best suited to rebuild and work with scan data. For this example, I'm going to use a chair shell that I modeled using Blender. The goal will be to recreate this surface and give it some thickness. In Plasticity, you can use the spline curve tool and snap the points directly onto the imported mesh. It's really convenient because it allows you to perfectly recreate the shape of the chair. I'm creating one spline for the outline and one for the center. As you can see, it's very simple and intuitive. Here, I'm using too many points to create the splines. Just a few would have been enough. I mostly wanted to test how well the spline snaps to the object. Once I've created my splines, I can easily recreate the surface using a loft operation and then give it some thickness. Now let's take a look at FreeCAD. There are several ways to create splines on a mesh. In my case, I chose to use the Curves workbench. There's also an option in the Surface workbench that lets you create a spline by snapping points onto the mesh, but I find it a bit inconvenient to use. The first step is to convert the mesh into a solid using the Part workbench. Then, I'm going to enlarge the object's points to make them easier to select. Next, I switch to the Curve workbench and, while holding Control, select the outer points of the chair. Once the points are selected, I use the Interpolate tool, which creates a curve based on those points. Then I repeat the same process for the central spline of the chair. Next, I go back to the Part workbench to extrude the central line. Then I can create the surface. To do that, I switch to the Surface workbench. Using the Filling tool, I select the boundaries, making sure to apply the G1 continuity constraint on the central boundary. After that, I go back to the Part workbench to create the symmetry and the 3D offset. I sped up the video to make it clearer. In the end, we get a similar result with both programs for this case. I think we can now move on to the overall conclusion of the video. Do you remember the animation at the beginning where I said these two vehicles perfectly represent the philosophy of the two programs? For me, Plasticity is the fast car. It's sleek, fast, and designed to go full throttle, delivering a smooth, rapid experience for specific tasks like complex surfacing or concept modeling. It's built for speed and precision in a very focused environment. On the other hand, FreeCAD is more like a rugged 4x4, versatile, reliable, and ready to handle a wide variety of terrains. It's not just about speed, it's about adaptability. FreeCAD can take you from mechanical design to architectural projects, from parametric modeling to complex assemblies. It may not have the lightning-fast feel of that Ferrari, but it's your all-terrain vehicle for practically any CAD challenge you throw at it. For my 3D modeling needs, I have to use both, because each one shines where the other falls short. For creating concepts or complex surfacing, Plasticity is truly the software I need. For simpler designs where I need to make more tweaks or adjustments, or even when I need technical drawings, FreeCAD is my go-to choice. For me, it's the perfect combo to model just about any 3D object. On top of that, both programs are compatible with Linux, and Plasticity's license is affordable and a one-time purchase, around $150, compared to other packages like Fusion 360 or Onshape. Let me know in the comments which software you use and why. I hope you learned something from this video, or at the very least, I hope it entertained you. Thanks for watching.